What's going on, fellas? My name is Stephen Kim, and today I'll be showing you how to do mental math in the easiest way possible. So a lot of times I get from my students saying, oh my God, I'm panicking because my teacher is not letting us use our calculator for this one test. And I'm like, why is that the case? Well, it's because we're so used to using our calculator that when somebody doesn't let us use it, we start to panic because we know it's going to take a whole lot of time just to multiply a few things, right? And especially now that the SAT has changed their format of the math section into two different portions, right? The first portion, you're allowed to use your calculator, but the second portion, you're not allowed to use your calculator. So, today I'm going to show you a little trick on how to do those multiplications in an easier way than we usually do. Hopefully it'll save yourself some time and make your processes a little more efficient in terms of doing your homework and taking your test and so on, right? So today we're going to take an example of 17 times 13, and I'm going to try to do that 17 times 13 in 3 different ways, and whichever way you like, whichever method you like, whatever floats your boat, take that, practice that, and really master it so that you can make it into your own skill so you can use it for various things you'll be doing from now on, right? So let's jump right into it. Method number 1. This is the method that I like to use. I've been using it since high school, which is like 9 million years ago. It's really been helping me a lot till today. So if this is your way, take it. If not, wait for the other 2 methods. So 17 times 13. What do we usually do, right? This is what we usually do, correct? 17 times 13, we write it like this, and we go 7 times 3, which is 21, since it's 2, and then the 2 go up here. 1 times 3, that's 3, and then 2, and it's 5 here. 7 times 1, and then 7, and 1 times 1. So it's 221. How long did that just take? I mean, when do we have all the time to do this, right? I mean, we've got like only 52 minutes for that one chapter test, and we can't possibly be spending like 2-3 minutes just to multiply this thing, right? So, let's get to the method number 1 and see what it's all about. So, I'm going to write this 17 times 13 just slightly in a different way, right? I'm going to put 17 times 13, but I'm going to say 10 plus 3. Because is that 13? Yeah, it's still the same thing, right? 17 times 13, 17 times 10 plus 3 is still 13. Now, and I'm going to use something called the distributive property, which hopefully we all learned back in what, 4th grade, 5th grade math? Okay. So, multiply this, and then multiply this, and then we add them, right? So multiply this, 17 times 10. Can people do that quickly? I hope so, because what is this, 170? Duh, it's just 17 with a 0 next to it, right? Okay. 17 times 3, that's 51. Hey, still 221, right? And some of y'all might be thinking, oh my God, isn't that like a longer way to go about it? Well, no, because if you master this piece, this is what happens. Even if I'm throwing any other number, like for example, 12 times 14, right? I don't need to do that on the paper. I can just be like 12 times 14. Okay, well, let me reverse that. 14 times 12. That's 14 times 10, and then 14 times 2 added, right? 14 times 10, that's easy, 140. 14 times 2, 28. 140, 28, 168. Bam. Now, I'm speaking all these processes out. That's why it looks like, it seems like it's taking longer than if you were to just write on the piece of paper. But if you really practice this method, my friends, it's going to accelerate your mental math method like crazy. So, if you like it, go ahead and try practicing it. If you're still hesitant to use it, if you're like, oh, I don't think that's for me, well, don't use it. We'll jump right into the method number 2. So, method number 2. This is a little shortcut. So still, 17 times 13. And this is what I'm going to do. I'm going to do 7 times 3, which is 21. That's easy. We can all do that. And what I'm going to do next is I'm going to take this 17 and then I'm going to add it to 3, which is what, 20, and put it right here. Make sure to shift this one over here. So put it right there. And this still comes down to 21. And you might be thinking, he probably just grabbed a number that just happened to work and it's probably not going to work on other numbers. Well, for all of suspicious fellows out there, let's do another example, right? Not 17 times 13, something random. I don't know, 18 times 16. Let's do that. Okay, 8 times 6, 48. 18 plus 6, which is 24, 288. If you're suspicious, go ahead and punch it in your calculator. If it's not 288, please go ahead and press that dislike button right now. Right? Okay. So, some of you are probably wondering, okay, well, I get that. Now I know that it works, but how does it exactly work? Like, what's the secret behind it, right? So, I'm going to show you how this exactly works in a diagram. And if the diagram doesn't really make sense to you, don't worry too much about it, okay? So, let me show you in a diagram. Let's try doing the 17 times 13 in terms of using a diagram as if we were to find an area of a rectangle. So let me draw a rectangle that is 13 by 17. It might look something like this, 13 by 17, right? And let me cut this rectangle in 4 different pieces. Now, you might be thinking, oh my God, like I'm already lost. Like he's drawing a rectangle. Oh my God, I hate diagrams. If it doesn't make sense, like I said, that's fine. But if it does, then, help yourself to know the cool stuff. Okay, so I'm gonna divide it into 4 different pieces. And I'm gonna say this is 10, 3, still 13, and 10, 7, still 17, right? So 13 by 17, okay? Now, let's find area of all the 4 sections. This is 10 by 10, so 100. This is 7 by 10, so this is 70. This is 10 by 3, which is 30. And this is 7 by 3, which is 21. Okay. What the hell is he doing, right? Okay, well, let's get back to what we did before. 17 times 13, this is what we did before, right? 21, and then 17 plus 3, 20, and we put it down over here, and 221. Well, remember, guys, technically, since we shifted this 20 a little to the left, there's a little missing 0 there, so technically this is supposed to be 200, right? So, let's think about these numbers. Okay, where did the 21 come from? Well, probably over here. I see that, right? So, the 21 is over here. But you're like, 200? I mean, where'd that come from? I don't see it. 70, 30, 100. I don't see 200. Wait, hold up. 70, 30, 100? What do I get when I add them? Holy crap, 200, right? Okay, so maybe that's where it came from, but how does that still explain this whole thing? Well, check out what happens. So I'm going to erase this for a second. What if I grab this 30 over here, this little portion, and what if I move it to over here? So check out what happens, okay? So I'm going to move this guy. I'm going to grab it, tilt it, and put it right here and just stick it in there. And we'll see what happens, okay? So, we're going to take this guy and move it to right over here. What was it before? 3 by 10, right? So that's how it had the area of 30. Okay, so 3 by 10, area of 30. Look at what happens. Where did the 21 come from? Once again, right over here, right? We put a star here. Where did the 200 come from? Look at this. What is that? 10 plus 7 plus 3? 20 by 10. 20 by 10, which is 200. Right there. Now, That's the process behind how exactly the method 2 works. What did I say earlier? If this diagram doesn't make any sense, don't worry about it. Don't worry. Because as long as you know how to do this shortcut, I mean, who cares if you know this stupid diagram thing or not? I mean, if you get this, great. You just know a cool stuff that you can show off to your friends. You probably shouldn't do that because you're going to lose half of your friends. But if you know how to do this, I mean, your teacher's not going to ask you, okay, how did you do your mental math? Show me your process by drawing a diagram. Your teacher's not going to ask you that. All you need to do is just do your mental math under the given time, right? So if this makes sense to you, great, just move on. This diagram, good if you understand. If you don't understand, don't worry about it at all. Just act like you never even listened to this lecture about this diagram, okay? Just make sure you know how to do this one, okay? So that was method number 2. And let's finally move on to method number 3. All right. This method number 3 that I'm about to show you, it's going to have some restrictions on when you can use it, but I'll explain that as I present this method. So 17 times 13. This is what I'm going to do. I'm going to do 7 times 3, like the method number 2, so 21. And then what I'm going to do is I'm going to add the 7 and the 3, which is 10, right? 7 plus 3 is 10. And I'm going to put 1 up there. And then I'm going to add these 2, which is 2. And then 2 times 1, 2. 221. You're like, what the hell? Whoa, 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 whoa. How did that work again? Here we go again. 7 times 3, which is 21 here. And then 7 plus 3, which is 10. So I'm going to put 1 up there. And then add these 2 numbers, which is 2. And you're going to do 2 times 1, which is 2. And you put it right over here. And you're going to wonder, oh my God, that seems more complicated than number 2. It looks like number 2 is much, much, much easier. And you know what? I'm not going to disagree with that. But this method will not only apply to the ones with the 2-digit numbers that have 1 as the tens digit, but it's also going to apply to some bigger numbers like 33 times 37, 87 times 83, and so on. But here are the exceptions. Here are the restrictions that you should always remember when you want to do method number 3. The rule is the tens digit right here, they need to be the same. Whatever the number it is, it's 1 right now, but whatever the number it is, it's got to be the same. And the units digit should be adding up to 10. Let's try this one then. 8 times 2, 16. 8 plus 2, obviously 10. Put 1 up here, make it 2. 2 times 1, 216. Right? Now, let's move on to some bigger number then, right? Instead of just like 14 and 16 and so on, let's do some real bigger numbers, like 47 times 43. Once again, same process. We're still meeting the restriction, right? The tens digits are the same, and the units digit add up to 10. So 7 times 3, 21. 7 plus 3, 10. Put 1 up here. That's 5. 5 times 4, 20. Could we have done this 47 plus 47 times 43 in such a fast-paced manner if we were to just do it in a way that we usually do? Probably not, right? It's probably going to take a lot longer than this, right? You want to see another one? Let's grab some like really big number now. What about like 82 times 88? You know what? I think we did 2, 8, and 3, 7 series too much. What about 4 and 6? Okay, 84 times 86. 4 times 6, 24, right? 4 plus 6, 10. Put 1 up here. That's a 9. 9 times 8, 72. Yeah, for all of you suspicious fellas out there, try punching this in your calculator. If it's not 7224, go ahead once again and press the dislike button right now, right? So this method, once again, the type 3 method, you can only use it if the tens digits are the same and the units digit add up to 10, okay? So those are the 3 different methods that you can use. And I have one more trick, which I'm just gonna call it method number 4. And this is another method that I like to use very often too. Now, we have a lot of 2 digits squared memorized, right? Like 12 times 12, 144, 11 times 11, 121, 13 square, 169, 14 square, 196, 15 square, 225, 16 square, 256, 17 square, 289, and so on, right? So we have those numbers memorized. So we're gonna make some use of those and apply to another shortcut method for mental math, right? So an example would be something like this. 12 times 13. Let's think about that. Hey, isn't this almost the same as this? What's the difference? Well, this is saying, hey, there is 13 of 12 or 12 of 13. And this is saying there's 12 of 12, right? So 12 times 12, 144, we know that. Because that's 12 of 12. But look at this. Isn't this like literally the same thing as this? Only except there is one more of the 12, isn't it? Because this is 12 of 12, but this is 13 of 12. So technically what this is saying is this. Hey, this thing is just one more of 12 than this guy right over here. So what do we know? 12 times 12 is 144. What did we just say? This thing is one more of 12 than this one. Hey, one more of 12, 156. Now there's an opposite way then. This is one way to go about. Let's think about opposite way. Let's take the same exact example and let's compare it to now 13 times 13. Let's think about this. 13 times 13, we know that, 169. We just have it on top of our head. Check this out. This is 13 of 13. But this thing is 12 of 13. Which means this thing is missing one of the 13 from over here. So it's going to be the same as 13 times 13, except now we're missing one of the 13. So we're going to subtract the 13 off. It's still 156. This method really applies to the already memorized values that we already have, right? So these are some of the mental math tricks that you can use when it comes to something like standardized test or some of your school finals or some of your 15 through 35 odds homework and so on, right? So hopefully this video helped you guys a lot. And I will be posting more and more tricks and tips on how to study math subjects and science subjects in more efficient manners, right? So if you like this video, please like this video and subscribe to my channel as I will be uploading more and more tricks and tips videos. And thank you for watching my video, and I really hope you guys can master this piece to really accelerate your math abilities. Thank you so much. And my name is Steven.